Hello everyone, welcome back to OnSite, where we're busy going through the grade 8 maths curriculum. So this is lesson 2 and we'll be dealing with the different properties of whole numbers.
So these are the property of whole numbers. So we start with the associative property, which is also known as the grouping property. So how this works is, for example, 1 plus 2 plus 3. We group these numbers like this, for example, and the answer we get is 6. So no matter how we associate the brackets with the numbers or group them, so if we change the bracketed numbers to these last two, the answer will still be 6. And that works with addition and multiplication. So if it's 1 times 2 times 3 like that, it will be 6. And if we change this again with 1 times 2 in brackets, that's how it works with multiplication and addition. We'll get the same answer regardless of the bracketed numbers.
So the second one is the commutative law or the commutative property, and what this basically tells us is that you can write it in any order. So in other words, you could write, if you say 1 plus 3 plus 2, it will be the same as saying 3 plus 2 plus 1. So you can swap those numbers around. So that's the same, and it pertains to the same as if you do multiplication. It'll be the same way as what you're doing it. It'll be the same, and you'll get the same answer. So these properties all pertain to addition and multiplication. So the next one you get is the distributive property, and basically this is when you do multiplication. So if you have 5 and you have 3 plus 2, so what that means is that 5, remember that there's a dot symbolized there, and that means multiplication. So it means 5 times the 3 and then 5 times the 2. So that becomes 5 times the 3, which is 15, and 5 times the 2, which is 10, and that gives you 25. So that just means that that pertains to each one. You're distributing the 5 over to the 3 and to the 2.
So the last one that we're doing is the identity property. So in multiplication and addition, how it works is in the identity, we'd like to have a number that we apply to the equation that keeps it the same. So for example, in addition, 7 plus 2, for example, is equal to 9. So what number will keep that equation the same is 0. So if we add a 0 on this side, we'll still get 9. So that's the additive identity, and the multiplicative identity is the same. Whereas in the same sense, we want to keep the equation the same. So 7 times 2 equals to 14. So we need to ask ourselves, what do we times by that equation to keep it 14? So that answer is a 1. So the first one is the additive identity, and the second one, which is 0, and the second one is the multiplicative identity, which is the number 1.
So those are some of the properties of whole numbers, and I hope that is of help to you.
So the next operation that is important to remember is inverse operations. So those are addition and subtraction and multiplication and division. But we'll go through an example with you so that you understand. So for example, 500 plus 300. That will give us 800. But how inverse operations works is, how can we reverse that to get back? So in addition, the inverse operation of the plus is the minus. So if we take 800 minus 300, that will give us to 500. So the same way that we added 300 to get 800, if we minus 300 from that, we'll get back to where we started. That's how the inverse operations work. So that's addition and subtraction, how they work. And the next inverse operation which we'll be going through is multiplication and division. So if we take the number 20 and we times it by 30, for example, we get 600. Now when we take that 600 and we divide it by 30, we get back to 20. That same number we started with, we can get back. So the sign, the multiplication, is inverted by the division sign. So we end up back where we started. So So that's the inverse operations, and I hope you find that useful.
Okay, so the next topic is division by 0. So if you take 0 divided by 10, that answer is always 0. Any number divided by 0 is always 0 except 0 divided by 0, which is undefined. So if you take 10 divided by 0, that number is undefined. So if you have a sum where it says A divided by A, you have to say there where A is not equal to naught, that answer is 1. So very importantly to note that A cannot be naught, because otherwise if A is naught, that also becomes undefined. Okay, so now we're going to go through some of revision from previous years, where we're going to talk about factors, multiples, prime numbers, and composites.
So factors, for example, let's take the number 16. So we have to multiply numbers that make up the factors of 16. So if we take 1, for example, we'll start from the beginning. 1 times what gives us 16? So 1 times 16 will give us 16. So the factors so far of 16 we have is 1 and 16. So that is a factor. So we can keep on going up. So 2 times what gives us 16? 2 times 8. So 2 and 8 are factors of 16. And so we can't say 3, because 3 doesn't multiply by another number to give us 16. So we can take the next one, and that's 4. So 4 multiplied by what number will give us 16? And the answer is 4. So these are the factors of 16, because it has to be below that number, so we could see already that we got all the factors for that number. And so the next one we come on to is multiples. So multiples of 16, since we're dealing with that number already, is just you timesing it by the next number. So timesing it by 1, timesing it by 2. So the multiples of 16 will go on all the time. So 16 times by 1 is 16. 16 times by 2 is 32. And you can keep on going. 16 times by 3 is 48. So you can always add 16, and these become multiples, so they'll continue. So those are the multiples of 16.
Okay, so the next part we're dealing with is prime numbers. So prime numbers are numbers that have as factors, which are these ones here, which have factors, only 2 factors, which is 1 and the number itself. So it doesn't have more than 2 factors. So if you're talking about, it excludes, always there's a debate, it excludes the number 1. Because the number 1 will have a factor of 1 and must have a different number here. That's why we say it has to have 2 factors, but there must be 2 different factors of 1 and the number itself. So number 1 is not a prime number. So the first prime number you get is 2, because the number 2 has got a factor of 2 and 1, and that's the definition of a prime number. A prime number has only 2 factors, 1 and the number itself. So the next one will be 3, and 4 is not a prime number because 4 has got the following factors: 1, 2 and 4. So it actually has more than 2 factors. So this will form a different number or fall into a different category, and that category is called a composite number. So a composite number has more than 2 factors. So for example, if you say 8, what are the factors of 8? So that will be 1, the number 1 and the number itself, which is 8, but it will also have 2 and it will also have 4. So as an exercise, maybe what you do is, for the first numbers from 2 to 20, try and classify which numbers are prime numbers and which numbers are composite numbers. And then see how you come up with that. This is just the revision of those numbers. We will, in the next lesson, lesson number 3, we will actually use all of these factors and all these numbers that we use a little bit different.